All right, welcome. So today we're diving into a really big challenge for any software team, right? How do you make sure every single code change is solid and secure, but without grinding everything to a halt? Well, we're going to architect a solution for that right on AWS. Think of it like a digital assembly line for your code, a system that totally automates the whole quality check process.
I want you to just think about this for a second. What if every single time a developer on your team saved their work, a completely automatic process just kicked in to make sure that code was high quality, secure, and totally ready to go? That's the real promise of continuous integration, or CI, and it's exactly what we're going to lay out today. The best way to wrap your head around a CI pipeline is to picture a factory assembly line. Raw materials, in this case, our raw code, they go in one end, and a finished, quality-checked product pops out the other. It's all about automation, consistency, and, of course, speed.
So, to really get how this assembly line works, we're going to follow one little piece of code on its entire journey. It all starts with a commit. Then it goes through a build and test phase, it gets turned into something called an artifact, and finally it gives us that all-important feedback. This is our roadmap for the next few minutes. So how does this whole automated thing kick off in the first place? Well, it all starts with a single, super simple action from a developer. That one action is the trigger for everything else that's about to happen. So the journey begins the very moment a developer pushes their code changes to a repository. It honestly doesn't matter if your team is on GitHub or if you're using AWS's own code commit. That push is the trigger. It's like flipping the on switch for our entire digital assembly line. Okay, once that code is in, it enters what I think is the most critical phase, the proving ground. This is where we find out, does this new code actually work? And does it meet our standards for quality? Now, the engine of our AWS assembly line is a service called Code Build. And this thing is fantastic because it's a fully managed build service. So what does that really mean for you? It means you don't have to set up or manage any servers. Nope. Our job is just to tell it what to do with our code, and it handles the rest. So what does Code Build actually do? Well, let's say you've got a Node.js or a Python web app. Code Build will compile it, but then, and this is crucial, it'll run all of your automated unit tests. Those little checks that make sure individual pieces of your code are working like they should. And as we'll see, you can also set it up to run basic security scans. It's basically our automated quality inspector on the factory floor. And this quote right here really gets to the heart of what an architect should be thinking about. Look, you could get totally lost in the weeds, tweaking complex configuration files, but the real goal here is to master the concepts. Understanding the stages, the artifacts, and those feedback loops, that's what lets you design a system that's truly effective and, more importantly, scalable. All right, let's assume our code passes all those checks in the build stage. Two really important things happen. One, we get a finished product, and two, we get the results of that inspection. Both are super important. So that finished product has a name. It's called a build artifact. This is the actual tangible output of our pipeline. It's not just raw code anymore. It's a neatly packaged, versioned, and validated component. It's kind of like a piece of flat pack furniture, right? The raw wood's been cut and drilled, and it's all boxed up with instructions, just waiting to be assembled. This artifact, whether it's a Docker container or a simple zip file, is ready for its final destination, which is usually deployment. And this brings us to that crucial feedback loop. See, Code Build doesn't work in secret. It reports its results, success, failure, all the logs, the test outcomes, right back into the AWS console. And for a development team, this is a total revolution. Instead of waiting for hours or maybe even days to find out if a change broke something, the developer gets an answer almost immediately. It transforms bug fixing from this painful archaeological dig into a quick, simple correction. It just keeps the whole team moving at full speed. Okay, so we've got a basic assembly line up and running. Awesome. Now let's put on our architect hat. How do we use this pipeline not just for speed, but to actively enforce our quality and security standards across the entire organization? Just look at this comparison. A pipeline without any defined standards might be fast, sure, but it's also going to be inconsistent and pretty risky. An architect's job is to design a pipeline that isn't just fast, but is also reliable, secure, and predictable. The pipeline itself becomes the tool that enforces your architectural standards. So where do you apply these standards? Right here in the code build stage. This is where you have all the control. For example, you can configure the build to fail if unit test coverage drops below, say, 80%. You can mandate that a basic security scan has to pass. And you can make sure every single project uses the exact same standardized secure build environment. This is a game changer because it completely kills that classic, well, it worked on my machine problem. This is how you get consistency and predictability, and these are your levers for quality.
All right, to wrap things up, let's just boil all this down into 3 simple foundational rules of the road. If you're building your very first CI pipeline, just start here.
First up, start simple. Seriously, don't try to build the perfect, most complex pipeline on day one. Your only goal should be to make it work end to end. Get a basic flow going from a code commit all the way to a finished artifact. You can always add the fancy stuff later, just get the assembly line moving. Number 2, automate that feedback loop. For developers, speed is everything. You have to make sure your pipeline gives a clear pass or fail message immediately. A pipeline that takes an hour to tell you about a bug isn't a benefit, it's just a bottleneck.
And finally, number 3, define your standards early. Don't treat quality and security like something you'll add on later. Build your non-negotiables, like minimum test coverage or a security scan, into the pipeline from the very beginning. You want to make quality the path of least resistance.
So, as you go off to design your own digital assembly line, the question I'll leave you with is this. It's not just about what your pipeline is going to do, but what standard is it going to set for every single piece of code that passes through it?